We've had several lessons working with proportions, and now we're going to take a look at another application of proportions, and it is called similar triangles. You might remember this topic from a high school geometry class, but maybe not. All right, it says look at the pair of triangles below. Note that they appear to have the same shape, but their sizes are different. These are examples of similar triangles. You can imagine using a magnifying glass to enlarge the small triangle and get the larger. This process works because the corresponding sides of each triangle have the same ratio. That is, the following proportion is true. A is to D as B is to E as C is to F. Now, we would probably never have an occasion to write all three of these ratios. We would just write two of them at a time. But similar triangles have the same shape. The lengths of corresponding sides have the same ratio. That is, they are proportional. Corresponding sides are proportional. And by corresponding sides, I mean those that match up. All right. Let's take a look at this first example. They give us in the statement that the triangles are similar. They have to tell us that. Find the missing length. All right, let's look at these lengths. Look for corresponding parts, meaning in the same position. Look for a corresponding pair where there are two numbers, and here is a set. We could say 9 is to 54 as 8 is to H. So if I went from the small one to the large one in the first ratio, I have to go from the small one to the large one in the second. 8 is to H. Now I have a proportion with an unknown, and I should be able to solve for it. All right, let's see. I'm going to do my two steps, and the first step is multiply 54 times 8. That's the cross product that has two numbers. So 54 times 8 is 32. Carry the 3. That's 43. So I have that product is 432. Step number 2 is to take 432 and divide it by the third number. So I have 432 divided by 9. 9 doesn't go into 4, but it does go into 43, so my answer will be this size. It's going to go in there just 4 times. 4 times 9 is 36. Subtract, borrowing. It's going to give me 7, bring down the 2. And it goes into 72 8 times, goes in evenly. So this is the quotient 48. The missing side, which is right here, is 48. What that actually means is that 9 is to 54 as 8 is to 48. All right, let's set up and solve another pair of similar triangles. This problem actually has two parts. Looking at the similar triangles, can you find the pair of numbers in corresponding parts that both are filled in with numbers? And I can. I can see that 27 is to 30 as, all right, I want to solve for x first. 45 is to x. And I'm going to solve that proportion. In a few minutes, I will come back and say, again, 27 is to 30 as, if I want to solve for y, I will say 36 is to y. So there are the two parts of my problem. Let's do this one. Step 1, I'm going to have 45 times 30. I can just write down that 0. and 0 times everything is 0. Then placeholder 0. 3 times 5 is 15. Carry the 1. That's 12, 13. So 1350 is that product. Step 2 is to take that product and divide it by the third number. That will help me find the missing number in the cross product. Let's see, 27 into 1350. Well, it won't go into 1, it won't go into 13, it will go into 135. Let's see. Let's try 5 times. 5 times 7 is 35. Carry the 3. That's 10, and 3 more is 13. That worked. Fill in with 0. This quotient is 50. That means that x is 50. I'm sorry, my work got a little crowded over here. See if I can be a little neater on this one. Now I'm going to solve for the missing side, y. Multiply here. Number 1, I have 30 times 36. Gives me zeros from this 3 for the 0. Placeholder 0. 3 times 6 is 18. Carry the 1. That's 9, and 1 is 10. 1080, and that's the product. Step number 2 is to take 1080 and divide it by missing number, which is 27. So 27 into 1080, and 27 won't go into 1 or into 10, but it will go into 108. That helps me see how many digits my answer will have. Let's say 4 times, and 4 times 7 is 28. Carry the 2. 4 times 2 is 8, and 2 more makes 10. That means all I'm going to have is a 0 there, so this is equal to 40. The y value is 40. So one proportion solves for x, completely separate proportion solves for y. All right, let's look at number 3. This one only has one part. We look at the triangles. We're going to find, triangles are similar, find the missing length, and I'm supposed to find h. Okay. Can you see numbers that are in corresponding parts? Yes, and you have choices. You can either, you're going to pick one. You can say 1.6 is to 4.8. 1.6 is to 4.8 as 5 is to h. That's one way. Or you could say 4.7 is to 14.1 because I have numbers there as 5 is to h. You can use either one of these because you have lots of information. You have corresponding parts with the 1.6 and the 4.8. You have another set of corresponding parts with the 4.7 and the 14.1. You don't need them both. These are slightly smaller numbers, so I'm not going to use this information. So, cross product, number 1, I have 5 times 4.8. Let's see, 4.8 times 5, that's 40, carry the 4, that's 24, 1 decimal place, that is 24. Step 2 is to take 24 and divide it by 1.6. I'm dividing by decimals. That makes me wonder about the kind of answer, and it says round to the nearest tenth. Okay, so I'm going to take 1.6 and divide it into 24. This has to be a whole number, so 1 place. Has to be a whole number, so 1 place. Put the decimal, and if I have to divide to the nearest 10th, I may have to go out to the hundredths. Let's see what happens. 16 won't go into 2, but it will go into 24. So my answer will look possibly like this. I may not have to go this far. We'll see. 16 goes into 24. It's only going to go one time. Subtract, get 8, bring down the 0. Well, that goes in 5 times. 5 times 6 is 30, carry the 3. 5 times 1 is 5, plus 3 is 8. This terminated. I don't have to, whoops. I don't have to worry about what's going on over here because it has terminated, and that's my decimal. So this is 15. If you wanted to, you could use this information right here, solve this proportion, and you will also get 15. Okay, so this one had extra information. Let's look at one more. In number 4, it says, how high is a tree that casts a 22-foot shadow at the same time a 7-foot pole casts a shadow which is 6 feet long? All right, we have got a tree. All right, please just, there's a tree. It is 22 feet tall. And, whoops, I misread it. How high is the tree? All right, we've got a tree. It says how high is it, and that's what I don't know. It casts a shadow. I'm just going to draw a line for a shadow that is 22 feet long. The sunshine would be up here, and there would be an imaginary line coming down like this. All right, at the same time, there is a 7-foot pole, and it casts a shadow that is 6 feet. So I have my height and I have my shadow. Once again, because the sun is coming down, it finishes up that triangle. Even though it's not stated, if you were to study the physics of the situation, these are similar triangles. And we should be able to set up a proportion. We know that 22 is to 6. Those are the shadows. As question mark, I'll use letter X. X is to 7. 22 is to 6. As unknown X is to 7. All I have to do is solve this. Step 1, I'm going to multiply 22 times 7. Let's see where I can get a little more room. It's 14, carry the 1. That's 154. Take that 154 and divide it by 6. I'm going there 2 times, that's 12. Subtract for 3, bring down the 4. It's going to go in there 5 times for 30. Remainder of 4. Let's go back up and look at the instructions. Round to the nearest tenth. Okay. I'm going to have to add some zeros to get to tenths, and I'm going to erase this part. That was my multiplication part. Decimal point is there. Bring down a 0. 6 into 40 is going to go 6 times. 6 times 6 is 36. I get a 4. Bring down another 0. 6. 36, subtract for 4. You can see the repeating pattern, but this problem said to round to the nearest tenth. Now the first 6 is in the tenths. The 6 behind it says to round up. So this is approximately 25.7 feet. So this was an application of similar triangles. When you see shadows of vertical figures and you can create a triangle, they turn out to be similar triangles. And so that can be used to make some calculations. Okay, work with your similar triangles and proportions and do that assignment.